Give me an update on that, Mr. Deflagrate, sir. I'll tell you what happened. Awesome. So we have a good crowd forming this morning. Today we here in the New Hampshire, at least in southern New Hampshire, it is a little gray, but otherwise a nice day. I'm waiting for some check-ins on YouTube. You are correct. There was a button that wasn't hit, which is just weird. Just came on. Okay, excellent. So, hey Bart, welcome. So on OBS, on OBS, there's a counter on the bottom, a little timer, and it says live, and it has a counter that ticks up. So I'm looking at the counter, and it's ticking up, and I'm like, everything's cool. And of course, there's a button that says go live. Didn't I? How come I'm not? I thought it anyway. Tested the imbalance on the wheel. It's 0.11 millimeters per second at 2,700 RPM. Okay, fair enough. But it's not zero. And that's part of what we're going to be talking about today. So I'm glad you brought that up. Ali, hi. Cap Julian, welcome aboard. Waiting for somebody to check in on the chat in the YouTubes. So yeah, we do have an interesting topic today. We're going to be talking a little bit about Henry's surface finish problems in specific, but then we'll talk about surface finish in general. But we're not going to get quite as deep as some friends of mine would like us to get. But we could do that another day. This is sort of today is basic. What do I have to do to get a good surface finish? And then what do I do after I use the PFG stones and find out that my surface finish isn't quite as good as I thought? So there's a couple of interesting things here. Let me go I got to go grab a grinding wheel for the discussion, and I'll be right back. So the wheel I grabbed is the wheel that actually came with the Okamoto grinder. It's a Mitsui grinding technology. They also go by MCT, and it's a white wheel. It's probably 46 grit. You know, pretty dense. So this is probably your basic 46i. Henry says PFG stones are evil. Yeah, well, sometimes you need evil. So we're going to use this as our discussion, and we'll get into that in a few minutes. Yeah, listen, PFG stones reveal the truth, and if you can't handle the truth, you should, go into politics where you don't have to worry about the truth. I'm just going to bring up here on my screen the YouTube channel just to make sure that what I think is getting out is actually getting out. YouTube is running behind. Yeah, can you just do a comment in the chat? That would help me convince myself that it's doing its thing. Yeah, it says live, and I show live. Okay. So I'll just shrink this to a little tiny window and stuff it over here. Excellent. Good. Fad Radcator, welcome aboard, sir. I have run your the second pass on your parts is sitting on the printer waiting to get cleaned up. And I'm going to do that today. Okay, there we go. Avery McCall, welcome aboard. Almost Machining, welcome aboard. Carl, I see you. Brian, welcome. And thank you for your other username. And Kevin is here. We could start. Excellent. I'm going to pop this out, I think. Yeah, that's working. Put that over there. And shrink that a little bit. All right, I got you guys. So that's the topic today, is kind of about surface finish. And in specific, we're going to use Henry's problems that, well, not problems, but his discoveries. That's a better way to say it. The discoveries that he made this recently in the last day or so, and we're going to use those as sort of our springboard for talking about surface finish. So we'll get into it. I'll give you some old business. We didn't have a live last weekend. It was the long weekend, Labor Day weekend here in the United States, and it was a 3-day weekend, and I kind of took a 3-day weekend. So we didn't have a live. I did do some grinding last weekend. I did do some grinding yesterday. I finished up a bunch of minis. So actually today I'm at on my own recognizance. The problem is that in my upstairs job, I have some work to do, and I'm probably going to do that this afternoon because I have to. It's one of the things that happens when you're self-employed. You work all the time. So probably this afternoon I'm not going to be playing in the shop. I'll be upstairs working. But Henry inspired me to want to do some grinding today, to work on some pieces for show and tell. But I think we have enough here based on what he sent. So, as always, if you have any questions, please put them in the chat. Or on Instagram, if you put it in the question button, that also is excellent because we can bring it up and show your question to everybody else. So let me preface this by saying that I have, only about five years or so of grinding experience. I am not a grinder hand that's been doing this for 30 years. I have not been working in a tool room for 30 years. So I am literally on your side of the table. If you're a student of grinding, I'm a student of grinding. So I think my discoveries are as they're beginners' discoveries. Grain size, welcome aboard. That's a great name for hanging around a bunch of people with grinders. How is the weather down there? Well, no precipitation. It's gray. It's a little humid, but that's about it. I don't think we're getting any precip today. And we got a lot of rain in the last couple of days where we got a good soaking, which we desperately needed. So things are greening up. How are you guys? How are you doing up there? Just Palin, welcome aboard. So, all right, so let's kind of get into it. Of everybody that's online right now, in chat, just give me a yes or a hand or something if you have a grinder and you're grinding stuff on a semi-regular basis. Henry says, just stoned a parallel out of that set, and the original surface finish is far worse than what I did. Perfect. Okay. So Almost Machining says 5. Does that mean 5 years? 5 grinders? Brian says yes. Bart is hands up. Of course, Henry, you're already hands up. 5 grinders, okay. Almost says 5 grinders. So I think we, most of the guys that are currently live are grinder guiders. Heinrich says yes, cylindrical grinder. Excellent. Kevin Blodgett says, I have a D-bit grinder. There's nothing wrong. We're not going to shame you. We're not going to D-bit shame you. So Almost also says he has one in 4 large pieces and a D-bit grinder in pieces. That's cool. I can't see which. Oh, Grain Size has the little funny hat. Okay. All right, cool. So we're talking to the right guys. So let me walk you through the conversation we had this morning, Henry and I, on the the doobly-doo. And Henry says, just one surface grinder, a pretty old machine from Young. And that's pretty cool. Okay. So, Henry, do I have your permission to share your photos that you sent me this morning? BFD says, we got the rain too. Leaves are changing faster this year. Plus size fall weather. Not sure if Mount Washington has snow yet. That usually determines our fate up here. And Qualified Monkey, that's the best name I've seen all morning. Welcome aboard. Bob Labs says he doesn't have a grinder yet. Okay. All right. Sure. So I have permission. Excellent. It's always easier to seek forgiveness than permission, but I'd rather have permission. So Henry sends us some photos this morning, and we start talking. And he, this is what he's doing, right? He's got these parallels. I guess now we know they're parallels, and they look good. Doesn't that look good? Isn't that a good-looking picture? Looks pretty sharp. Okay. And then, then what does he do? Come on, guys. What do we guess that he does? He reveals the truth. So after he does this, which is a grind that you'd be proud to take home to mother, right? He gets out the PFG Stones and he stones the grind. Now, what does that invariably do? What does it always do? I'd like to think of it as it now gives you more information. So yes, Kevin says it well. It reveals all. There's nothing wrong, if this meets requirements and meets the James Howe says, it makes you sad. It's not supposed to make you sad. I will teach you the antidote to sad. So if this meets requirements and this does everything you need to do, you're done, right? So that's true. But I guess here's one of the big punchlines for what I have today, and that is there's no such thing as zero. There's no such thing as perfect. We work to within tolerances. Another fine podcast, by the way. We work till we're within tolerances and then we're done. But the problem with grinding is we generate some gorgeous grinding like this, and then we look at it and we say, oh, it's gorgeous and it's perfect and it measures what I need and it's better surface finish than I need, and I'm done. Are you getting any information from this? You're not getting any information for this. And I could tell you, I know it's hard to see, I printed a photo and now you're seeing it through a camera. But when I looked at his photo, it looks great. It looks like a great grind. All of you would be proud to turn out a grind that looks like this. So the problem with that is is that now we don't know anything. We look at it, we say, we're done. We're at zero. We're at zero errors. No, you're not. You're at a level of error below the threshold, and that's why you're done. But if you can look at your errors and you can see what's there, you could still improve your process. Would you agree with that? So that's what the PFG Stones do in grinding. One of its jobs in grinding is you take that gorgeous, perfect surface and then you hit it with the PFG Stones. Qualified Monkey says, using precision ground stones is worse than alcoholism and drug addiction. I'm not going to argue that point, but I see where you're going. You start stoning everything. So when I made my first set of PFG Stones, oh, by the way, the set I just pulled out here is set number 2, okay? You see the 2 black dots right there? There you go. This is set number 2. Set number 1 is over by the grinder. So one of the first things I stoned when I made my my PFG Stones is I stoned a set of 1, 2, 3 blocks that I had sitting in the shop, which is probably, if I had to guess, I'd say 80 to 90% of people who buy PFG Stones, that's what they go and they do. They go hit the 1, 2, 3 blocks. And I saw stuff. I saw the fact that it was the grind was sinking when it was in line with the holes on the 1, 2, 3 blocks, and then it was rising, and that's where we were hitting the high spots between the holes on the 1, 2, 3 blocks. And I thought about it, and I went, okay, I think I know what's going on. I think the way they manufacture the 1, 2, 3 blocks is they have a wide grinding wheel, okay, and they're grinding across the holes, and when it hits the holes, it has less pressure, so it grinds down, and when it hits the space between the holes, it has more pressure, so it's riding up. And how many times do you think they spark out when they're making those $12 1, 2, 3 blocks? I would guess 0, right? Yeah, okay, perfect. And Henry says, we're going to get to that, Henry. Excellent point. Welcome, Taunus Mechanics. I've seen your name before. So anyway, we were able to take these 1, 2, 3 blocks, which seemed fine, and then stone them, and all of a sudden we started figuring out, oh, I think I know how these were made, and oh, I see there's a wave in the 1, 2, 3 block, and all of these things come out from having stoned it. And as I was joking around with Henry this morning, if you guys are on Instagram, my joke was that the PFG Stones giveth and the gray ScotchBrite taketh away. So, if you ever stone a surface because your grind is wonderful, but you want to see what's going on, and then you see the truth and you don't want to see the truth anymore, you take the gray ScotchBrite and you just ScotchBrite it and it will go away. K-Bonk says we need levels of PFG Stones, Rookie and Renzetti. Yeah, all I can tell you is, regardless of what level, always have the gray ScotchBrite handy. Oh, take care, BFD. We'll catch you on YouTube. He's got to run. What are the flatness specs on your stones? Well, it's an interesting question. It's going to be on the order of 50 millionths, half a tenth. But remember, they're also made out of rubber. So when you use them, you're putting pressure on them, even if you think you're not putting pressure on them. But basically, it's as good as we can get out of the grinder. And one day, it's on my list to do a video showing a flatness scan on those stones. So getting back to where we were, this is the picture. This is probably the best one. This is the next picture that Henry sent me that shows some of the things that, oh, hey, Wes, that shows some of the things that he started discovering. And you can see that there's two parallels there. One he did not stone and one he did stone. Okay. So now we're making, this is what we'd call a differential observation, right? So here's the one he did not stone, and it looks great. That's kind of the picture I just showed you. And all of a sudden, he shows this one, and the PFG stones start revealing some defects. And, at this magnification, we look at that and we see, oh, okay, there's like a couple of stripes of bumps, right? And now we start scratching our heads. And one of the first things we think about is, I wonder what step over he was using. Okay, Henry says he ground them next to each other at the same time, but you only stoned one of them. Is that correct? I believe that's because that's what I just said. I just want to make sure that's the truth. So we're looking at this pattern, and this pattern clearly has a repeating, rumble strip. And there's really about 3 of them. So all of a sudden we have some information that we could use. Now, one of the questions I asked, we're going to get some of the questions and answers out of order, okay? But one of the questions I said to Henry is, what was your step over? So first thing you need to know is he's using a 30 millimeter wide stone. Okay, thank you, Henry. He's using a 30 millimeter wide stone, and he was stepping over about 10 millimeters. So as I said to him, I like to think of it as in terms of the step over, in terms of the percentage of the width of the stone. So he was stepping over about 1/3 of the grinding wheel, okay? So the grinding wheel is 30 millimeters wide. He's stepping over 10 millimeters. He's stepping over about 1/3 of the grinding wheel. So when we look at those bumpity bumps that the PFG stones revealed, they kind of look about the width of one of his step overs. There's a hint there, okay? The second thing we notice is that the bumpity bumps were about the same frequency, or more correctly, we'd say spatial frequency, right? For each of those strips. So that kind of looks like wheel imbalance. Kinda. We're going to get to that in a second. So the knee-jerk reaction here, right, before we get under the microscope, and I have a couple of microscope pictures, before we get under the microscope, the first thing I said was, hey, Henry, did you balance your wheel? And he's like, yes, I balanced my wheel. Okay. And how did you dress your wheel? So he described to me that he dressed the wheel by passing his diamond 3 to 4 seconds it took to make it across the wheel, and it's a 30 millimeter wheel. Okay, that sounds like a perfectly reasonable dress. So if the wheel is balanced, which is another way of saying if we believe Henry and the wheel's balanced, then what is causing this thing that looks like imbalance? So the first thing is, it could just be imbalance, and that's okay. Because what's the catchphrase for today? There's no such thing as zero. So, if you balance your wheel, is it perfectly balanced? Of course not. You took it from 100 units of out of balance, and now it's 7 units of out of balance. But there's no such thing as perfectly balanced. So it is possible that these come from what Robin and I have been going back and forth over time with the term residual imbalance. This could be residual imbalance. But how come it's only happening a couple of times and not all the time? Another interesting question, right? So it happens 3 times across that part, and we said that his step over is about 1/3 of his wheel width. Is it possible that, I mean, I'd have to actually do measurements with a scale here. Deflagrate correctly points out, hey, Nick, welcome aboard. Deflagrate says, what about the wheel bearings? Yes, the wheel bearings could be a player. I'm going to talk about that in a second. Paul Morley says, is it happening in only one direction? Excellent question. So one of the things I said to Henry is change your wheel speed, change your table speed, okay, and see if the spacing changes. And we've had this conversation a couple times in the last few weeks. So if you change your table speed and the spacing of those bumpity bumps change, then it's associated with the wheel. And if you change your table speed and the bumpity bumps don't change, then it's associated with your table. So let's say you had a bumpy bearing in your table, which is entirely possible. If you went slow, then it would have the same number of bumps per inch as if you went fast. So that's how you diagnose whether it's your table or your wheel. In a lot of grinders, you don't have the luxury of changing the wheel speed. If you have a VFD, you could change the wheel speed. So you could do sort of the same thing. There's a couple of traps in there, which I'll talk about. Henry says 0.1 millimeters per second is like, I think it's per second squared, is like 0.0001 G. Yeah, it's real small. And that's why it doesn't show up here, but it shows up after you stone it. So we really are in the weeds here. And it's not even measurable. So we know we're in the weeds. So we're going to talk about that in a second. So let's go back. We could continue the diagnosis by saying change the table speed, grab the table throttle, and change it a little bit, and see if you could make the bumpity bumps get closer or further based on table speed. If you do that and you establish that it is not associated with the table, in other words, there is a change in the spacing, now it's associated with the wheel. Now it's the first knee-jerk reaction is it's wheel balance. Now, you may recall, and correct me if I'm wrong, Henry. Yeah, Paul Morley says, potentially a resonance that is playing a factor when the relative speed of the traverse is different in one direction versus the other. Yeah, I'm going to take a little issue with it. Yeah, you went to third order problems, so we'll talk about that. So Henry says the grinder has variable speed and scraped ways, and the spindle bearings got changed 3 years ago. Sounds pretty skookum. Okay. So then we're going to look at the wheel, right? We're going to assume that the table's okay, and we're going to look at the wheel. So I believe, Henry, you're using the fancy balancing system, right? That's why you're getting actual numbers. So Henry has this really cool balancing system which uses an accelerometer on the wheel housing and a box that looks at the time-based acceleration bouncing around, and then it gives him instructions on where to move the weights, and you could watch the vibration go down and down, and he's down to a really tiny level. And the table is hydraulic. Excellent. Thank you. So it is possible that it is possible that system, that spindle and wheel combination is in fact showing some residual imbalance, or it could be something else. So I'm gonna offer a couple of possibilities here. Yeah, let's talk about a couple of possibilities, and then we'll get into mitigations. Almost Machining says, did he dress prior to the last 2 passes? Henry, I think you used the same. You dressed once, and you got to this final grind. I believe that's what happened. Is that correct? I don't think he's dressing manually, so I don't think he's doing any kind of automatic dressing. So let's turn our attention to the wheel. I'm going to assume Bart wants to know, Henry, is the motor direct mounted or belt? So what everybody's doing, which I think is correct, everybody is looking for the imbalance, right? And looking for something that's going to introduce a vibration into the up and down motion of the wheel. That is a worthy search. But I want to put some other things in your head. Okay. Almost Machining says, is it possible that it's coolant/wheel binding and releasing at those particular times? What was the last pass done at a lower speed? All right. You guys are absolutely in second order diagnosis. I want to stay in first order, and then we'll get to that. Let's look at the wheel itself. Direct mounted motor and dressed once, but just took 0.01 millimeters. So let's look a little closer, okay? And then we'll get into it. Now here's a photo where it might be a little hard to see. On Instagram it's hard to see. On YouTube it looks actually pretty good. And what it's showing is those marks in a little more detail. Now, one of the things I find interesting in these marks is that you can pretty clearly see his dressing pass in the wheel. Okay, it looks like, it looks like some teeth in each of these stripes. And there's another hint there. So a lot of times when you generate a grind like this, you would go over it again and execute what's called a null pass or a spark out. And there's a good reason for that. You did it in 0.002 millimeter steps. Okay, so you dressed in 0.002 millimeter steps. Can somebody translate that for me into inches? I apologize. You might have, yes, I was just going there almost. Almost Machining says not deep enough. That's 8/10. 8/10 total or 8/10? 0.02, 0.0. Is that 8/10 total or 8/10 per pass? Yeah, somebody give me some math on this. .002 millimeters is what in inches, please? Oh, that was your surface grind. Okay. That was your surface grind. What was your dress depth, Henry? Thank you, grain size. Yep. Yep, no, that was his grind. I'm not worried about that. I'm curious about the dress. Okay. So here's the more important question, Henry. Did you do any spark out passes after that grind? Or was the last thing that touched the work was a grind, was a 0.002 millimeter grind. Dress depth was 0.1 millimeters. Okay. .1 millimeters. Okay. I think that even might be a little too much, but that's not, I'm not super worried about it. Okay, and you did like 10 spark out passes. Okay. Very interesting. So you did 10 spark out passes. When you did the 10 spark out passes, did it stop making sparks? Or was it still making a couple of sparks at the end of 10 passes? So what I would like to suggest, you know, the one thing we're assuming is just totally fine is the wheel. Okay? So the wheel is its own system, and the wheel has what appears to be a random distribution of grits and a random distribution of configurations. It is possible after you dress your wheel that you have a section of wheel that has a very high density of grits with points, and then you have another section of wheel that has a very low density of grits with points. So you could end up, I'm going to draw a picture here. You could end up with the face of your wheel looking like this, and the face of your wheel looking like this, and they're both at the same height, the dotted line, right? But the difference is that this part of your wheel here has much tighter space between the points, and this has a bunch of space between the points. And the spacing here is probably big, and the spacing here is probably small. So you could, yeah, that's where I'm going, Brian. You could end up with actually loading the wheel in these spots and not loading the wheel in these spots. And I know that you're not using flood, right? You're using, you were grinding dry, I believe. And almost there. See, we're thinking the same. I think Henry was grinding dry. Are you grinding dry? By the way, if all of this sounds like we're heading into the abyss of grinding can't be done well, that's not where we're going. There's some good news coming at the end of the rainbow here. So if you ground your parts, okay, after 10 passes, there was just like a few sparks coming from the part, which, by the way, is a really good sign. And you ground wet. Okay. That's interesting information. So if you ground, if your whole wheel looked like this, and you ground a part, and your whole wheel looked like this, and you ground a part, they could both, you know, be dimensionally exactly the same. Grain size says sometimes when you grind a previously ground surface, you do not reach the valleys of the previous grind. Yeah, okay, I like that. I believe that. So, you know, we're certainly looking below the level of normal, you know, observation on surfaces. We're under a microscope. We've used the PFG stones on them. I mean, we're down in the depths. We're just looking for what's going on. So my point is that the wheel can be inhomogeneous, right? It could have some areas that look like this at the surface and some areas that look like this at the surface. So here's my question to you. Which one of these would have more cutting pressure? This area or this area? A or B? Which one would have more cutting pressure? So I would offer that A would have more cutting pressure. The one near the ring finger. Yeah, we're in agreement. So you have more cutting pressure here and less cutting pressure here. So you have this perfectly dressed wheel. Hear me out. Perfectly dressed wheel on a perfectly balanced wheel on a perfect table with perfect motor balance. Okay? And you're going along, and some areas of the grind have higher pressure than other areas of the grind, which have lower pressure. I say this is going to have higher cutting pressure than this. This is going to have lower cutting pressure, okay? So if you have high pressure and low pressure and high pressure and low pressure, what does that behave like? I think it behaves like an imbalance, even though there's no imbalance. But you're saying, wait a minute, we have a very high quality wheel here, and it's obviously, because I'm looking at it, it's obviously homogeneous. What I'm suggesting is, okay, so Deflagrate says B should be higher pressure because it has fewer points. But he's grinding wet, and there's less room here for his coolant. This is a really good argument. It doesn't matter what the answer is. Are they the same or are they different? And I'm going to say that they're different. So you could have a spot on the wheel which is acting high pressure and a spot on the wheel that's acting low pressure, and it's going to act differently. So my point being is that if you go across your work, you could end up with something that presents as imbalance, but it's not imbalance per se, it's inhomogeneity. I just won a $20 bet that I could put that into a live. It could be inhomogeneity in the wheel. Hypothesis. So what I said to Henry is, go dress off like 10 thousandths off the wheel. I said it in metric. Yes. Okay. Almost is thinking the same way I'm thinking. Let me read it, and then I'll tell you why I think we're heading in the same direction. He says, question, did he go to the same points for reversing the crossfeed, i.e., was there a lack of randomness, which is one of the secrets to removing machine issues? Yes. Being random, it's true. Being random is one of the things that you have to do in order to average things out. But I would offer that there's no linkage between his wheel position to the table position. So it would be really hard, unless you have a table issue, to get reduced randomness just for not changing your reversing points. I'd make that argument. But I like your concept, which is that some randomness is needed. When we do spark out passes, what are we doing? We're hitting each point on the work with more different points from the wheel. Aren't we doing that? We're increasing the randomness of what each point on the work sees. So my suggestion was that Spencer Tool and Grind, welcome aboard. O'Malley, welcome aboard. My suggestion was that he go dress off, do a heavy dress on the wheel, and then do his normal dress, and then dial his call again. Go run the part again, and then see if it improved, because you could have something going on the wheel. So that was an important thing. But the fact that this picture was just pretty amazing, in that it's showing you can see his dress in the wheel. Now the other thing is, I suggested that he needed a smaller step over. So once again, the way I think about roughing on the grinder is you're roughing with a big step over. In fact, you could rough with 100% step over depending on what you're doing. So you could literally go full wheel width, full wheel width, full wheel width, and then come in and do your finishing with a small step over. Something that Adam, the machinist, said, Adam Demuth, a while ago, which stuck in my head, was if you step over 1/2 of the grain size, you're going to get the best finish possible out of your wheel. Okay? I mean, think of your wheel as being a fly cutter with 1 point. What would you do if you had 1 point on your wheel? It's basically a fly cutter. That's what you would do. You would step over a fraction of the width of your point, and that's how you would get your finish. We do that on the mill all the time, right? On the wheel, we have many points, okay, in various random configurations, and we're investing in that randomness to give us our surface finish. Does that make sense? So by, the good news is, even if he changed nothing, okay, don't change the wheel. Don't change your dress. Don't change your speed. Change nothing except have a smaller step over, then a lot of these things might even go away. Further, if he lowered the speed of the table in the finishing passes, same thing, different axis. Now he's getting more points of the wheel hitting each square blivet of the work, and he's getting positive results from the randomness. So the two things you can do if you're going after finish, right? You can slow the table down, and you can lower your crossover, lower your step over. Take care, Paul. Thanks for being here. So those are things that you can do if you need to improve the situation. I will once again point out that the end customer was hypothetically totally happy with this. It met all requirements. So everything we're talking about now is that fine tuning. But if you're doing some stuff where, surface finish is everything, when I grind PFG stones, am I grinding to dimension? Absolutely not. I'm grinding to surface finish, effectively surface finish, right? So if I see some issues in surface finish, I'm either regrinding it or changing my process. Now my process has been really stable. Changing my process might be stop, dress the wheel. Okay, you're going to do something to the process to improve what you're seeing. So I think this is a really important point, which is that you can have a perfectly dimensioned wheel. You could have a perfectly balanced wheel. You could have a perfectly smooth table bearing, and you could still end up with these things. Henry says, I used a multi-point dresser. I think it's small bonded diamonds. I have also a single point diamond. Yeah, I don't think it's worth getting into the argument of multi-point versus single point diamonds. I was assuming you were using a single point, because quite frankly, if you have a multi-point diamond, the tallest one is probably going to do most of the work until it wears down. But your other parameters sounded just totally fine. So let's see. Yeah, and at the end of our discussion this morning on text, I said to Henry, one of the hints of sparking out a lot in support of an excellent surface finish is the fact that there's a knob on the Okamoto that says this. It says, how many spark out passes do you want? And it goes from 0 to 15. So you know, if your time doesn't matter, and you're about to go to lunch and you're running your Okamoto in semi-automatic mode, why not just turn it up to 15? You could. Does it hurt? No. Can it help? Yeah. So, but I just thought this was pretty funny that, this would not go up to 15 if somebody somewhere didn't think that 15 spark out passes had utility. I thought that was pretty funny. Okay. So I hope that this opens up some avenues of thought with respect to the fact that, hey, your wheel is not necessarily homogeneous. Your perfect balance isn't necessarily the whole story as to, what's going on. There could be some variation in cutting pressures that's causing the issue. Maybe some ideas about how to diagnose what you're seeing. And of course, the overarching message of this morning or this afternoon, is that the PFG stones reveal information below the level you've previously had. So once you stone the surface, you could start going to school on what you see. And as always, if the part meets specifications and you've stoned it and you've picked up all your information, you get out your gray ScotchBrite and you cover it all back up and deliver your parts. All right, so that's all I got today. Thanks, Henry, for providing the idea for the discussion today. And you guys are great. Thank you for all the inputs. There's a lot to talk about here. It's pretty awesome. And it makes me want to go play with the grinder for the rest of the day. Unfortunately, I got to go do something that is totally different for the rest of the day to make a client happy. So if you guys have any questions, we got 5 minutes left, and we're going to try to keep it sharp today. So any questions, pop them in the comments. Any questions, any topics. Ugly Skull. So amongst the things we did not talk about today, which I think is important to point out, is we didn't talk about what the material was. I'll explain that. We didn't talk about what the material was. We didn't talk about what the wheel was. None of what we talked about had any impact on that, unless you were doing something really stupid like I did when I tried to use an aluminum oxide wheel on a chuck. That was a disaster, and that was part of my learning. Henry says he will test everything and give feedback. I'm looking forward to your feedback, Henry. That's awesome. Thanks, Bob. Thanks for being here. Thanks, Brian. I don't know about lessons, but it sure was a bunch of people thinking. That was good. K-Bonk says it was a fun brain tease. We're here to tease. That's why we're here. Okay, so in order to have all the fun and merriment that Henry had, you need a set of PFG stones in order to join in on the fun. Bart says, what to look for in good grinding coolant? Can talk about it next time. That's a good question. I'll tell you what's going on in my shop. I use one coolant for everything, and it's Qualichem Extreme Cut 250. Now, my good friend John Grimsmo up in the Canada, he uses 251. And I think that just, they're all a little different, a little more lubricity or whatever. I use Qualichem 250, 7% in the mill, 3.5% in the grinder, and whatever looks like coolant in the saw. And also on the lathe, I use the 7% nominally, but I don't get too whipped up about it. So I've been using that. It works great. It tolerates the filtering that I put it through. So that's what I've been using. Qualichem 251. Generally, you're going to use a coolant that is more cooling than lubricating. In the mill, you might use something that's more lubricating than cooling. It all depends. All right. Well, we're coming up on the end here, and it would be I would be remiss not to point out that today is September 11th, and it is a day of two things. Number one is remembering what happened 21 years ago, but number two, it's continuing doing what we do, and that's why we're here. My philosophy is on September 11th, we don't cancel anything. We don't take the day off for anything. We keep doing what we're doing. And that's my response to that. So, guys, I hope you have a great rest of your day. Nick says, is anybody using Qualichem 292? The salesman keeps telling me it has their secret titanium killer in it. I don't know. So if anybody's using Qualichem 292, get back to Nick, who is 0NL10 on Instagram. Thanks for being here. This was fun. We'll do it again next week. I'm hoping to get us into a new phase of having some guests, which is probably going to end up being a YouTube event only, but we'll talk more about that. I know I've said that like 5 times already. I need some time to plan it. It gets a little more complicated when we do that. Have an awesome weekend. Go do some fun stuff. Thank you, Nick. You understand. And we'll see you guys next week. Oh, I didn't answer the question. The hat. Sorry. The hat is the School for the Museum of Fine Arts at Tufts University. A great deal of my money goes to the School for the Museum of Fine Arts at Tufts University. Conjette.art is the website. CONJETTE.art. Conjette.art. And you'll find out why a lot of my money goes to the School for the Museum of Fine Arts. All right, Kevin, take care. K-Bonk, have a good one. And Mehdi, you won the award today for coming in just as we were leaving. But you could take my table. Take care, guys. You're awesome. Catch you later.